Welcome. Our lecture for today will be multiple regression analysis. We will start our discussion with the fundamental concepts, just the difference between simple and multiple regression. Then we will explore the assumptions required before we can run this multivariate statistical technique. And then in the last part of our lecture, we will run and interpret sample study using MRA and SPSS. So let's get started. Let us start first with the definition of regression analysis. According to Amar Sahai, it is a mathematical model that explains the relationship between two or more variables. Okay, so if you have two variables in your conceptual framework, one dependent and one independent variable, then you have to use simple regression analysis. However, if you have more than two variables, independent variables, and one dependent variable, then you have to use multiple regression analysis. Okay? So para mas clear natin yung difference ng simple regression at saka multiple regression, let's take a look at some examples here. So the common example is the sales, kasi sales is one of the important aspects in business. Okay, so that is why it is important to understand what factors that influences or affects sales. So one of those is advertising expenditures. So if you want to determine the effect of increasing or decreasing advertising expenditures toward sales, so we can do a simple regression analysis. In this conceptual framework, the advertising expenditures is the independent variable and the sales is the dependent variable. So we can graph the two variables in a scatter plot. So in this particular example here, yung advertising expenditure natin, since it is our independent variable, we will plot it in the x-axis. And then our sales, since it is our dependent variable, we will plot it in the y-axis. So take note guys, in our basic geometry, if you have 2 points, you can create an equation by connecting those 2 points. Okay? So using the equation y is equal to mx plus b. The y is the dependent variable, the m is the slope, x is the independent variable, and then the b is the y-intercept. However, in actual practice, there are hundreds or thousands of data sets. Okay, so we cannot create a line by connecting all of these points here. Okay, so you will not be able to create a straight line. So that is why the simple regression analysis will estimate a line. Okay, using least square method, that's the most common method. Using least square method, it will create or estimate this line here. So that line, since we already have that line, so we can already create a mathematical model in the form of y is equal to beta sub 0 plus beta 1x plus the epsilon. So the similarity is the beta sub 0 here, that is our y-intercept. And then the beta 1 here, beta sub 1, that is our slope. And then the epsilon here represents the residual or the error term. Bakit may residual or error term siya? Kasi yung kanina, yung dito na equation na yan, yung dalawang points lang, yung dalawang points natin, natamaan yung line natin, natamaan yung dalawang points. However, in simple regression analysis, maraming mga data points dito na hindi niya natamaan. Okay? For example, in this particular data point here, hindi natamaan ng line na yan. So the distance from this point to the estimated line, that is our error. So all of this error here should be represented in our model. So that is why we have an error term in this equation. Again, in practice, one variable may not be enough to explain the changes in another variable. For example, in this case here, we have the advertising expenditure at saka yung sales. Okay, other variables might affect also sales, such as customer satisfaction. Okay, so in this particular case here, dalawa na yung independent variables natin, so we cannot use the simple regression analysis. So that is why we have to use yung higher level na, yung tinatawag nating multiple regression analysis or commonly known as the MRA. Okay, so since tatlo na yung variables natin, so we cannot plot this one in a two-dimensional coordinate system. So that is why tatlo na yan. So, yung advertising expenditures natin, pwede nating i-plot dyan, at saka yung customer satisfaction dyan, and then yung sales natin dyan banda. So, since three-dimensional na siya, the line we will not be able to create a line there kasi tatlo na yung points natin. So, Amarsahay termed this one as the hyperplane. Okay? Yung hyperplane na ito, yung estimated regression plane, can be represented in this equation. Medyo similar siya compared sa simple regression analysis natin, kaya nga lang may nadagdag lang na ito, beta sub 2 x sub 2. So this represents the additional independent variables that we added in our conceptual framework here, which is the customer satisfaction. Meaning, if you are going to add another variable in our independent variable here, so mag-a-add lang tayo ng beta sub 3 x 3, so on and so forth. Okay? So, let us now discuss the assumptions for MRA. This is very, very important. In every statistical tool that we have to use, we have to check if pwede ba yung tool na gamitin natin using the assumptions. So, number one, the linearity of the phenomenon being measured. Number two, the independence of error terms. Number three, the normality of the error term. Number four, equal variance of the error terms. Since simple linear regression itself is a linear estimation, it is very proper na yung gamitin natin na mnemonics is line. Okay? So line, L-I-N-E. L stands for linearity, I stands for independence, N for normality, E for equal variance is homoscedasticity. Okay? So let us first discuss linearity. So by definition, according to Amarsahay, the relationship between the predictor and the response variable is assumed or approximately linear. In this particular plot natin, this is the dependent variable and then the y and then dito yung independent variables natin. Later on we will have a similar plot like this one in SPSS. So we can use this matrix plot and then we can also use the partial regression plot. So what happens if there is a violation or your data will not meet the linearity assumption? So you can use the transformation of data values or you can use the nonlinear regression. Okay, so next. So the next is the independence of error terms. So it means that the distribution of error is random and not influenced by errors in the prior observation. Mostly nangyayari ito if we collected our data over time. Okay? So if you're going to plot the predicted y and then the residual, dapat ganito yung plot natin para makita natin na there's no violation in this assumption. However, pag yung plot natin is ganyan yung itsura natin ng predicted value at saka yung residual, so there might be a problem with autocorrelation. Okay? Yung autocorrelation natin, we can check the autocorrelation according to Andy Fields using the Durbin-Watson statistic. So sabi niya na if the value is approximately around 2, so okay yun. However, pag less than 1 or greater than 3, there might be a problem with autocorrelation. So in order to test for the independence of error terms, we can use the residual and then the unstandardized predicted plot or the Durbin-Watson statistic. But in my case, I always prefer the formal test. Okay? So later on, we will do the Durbin-Watson statistic test. So what will happen if there is a violation? Again, you can do data transformation or you can use the generalized or weighted least square. This is according to Hasselwagen in 2016. So the third assumption that we have to check is the normality. It means that the error or residual does not significantly differ from normal distribution. This is according to Sahay 2016. So this assumption can be tested using two ways, using visual at saka yung formal test. Yung visual, we can do the histogram, box plot, at probability plot. However, yung formal test natin, we can do the Kolmogorov-Smirnov or the Shapiro-Wilks test. In this case, in my opinion, I will really suggest to do the formal test. Okay, kasi yung mga graphical inspection natin is very subjective. Okay? Other might see it as not normal, other might see it as normal. So that is why we have to standardize the test. So I would prefer to do the formal test. So what are the possible solutions pag hindi nag-normalize yung data natin or nag-normalize yung residual uh, terms natin? So we can do first, you can increase the sample size. Next is you can do data transformation. But first, you have to do preliminary check of your data. Your data, you can check for the outliers or the influential cases. So later on sa SPSS natin, we're going to show using the Cook's distance. So the last assumption that we have to comply is the homoscedasticity or the constant or equal variance of error terms. So by visual inspection, you can do this one. If the null plot looks like this, so okay yan. However, pag ganyan yung null plot, yung plot natin, this might indicate that our data set is not violates the assumption of homoscedasticity. Okay? So we can use, again, two-way. You can use the graphical inspection and then yung formal test. So yung graphical inspection, same as dito sa taas, you can do the residual at saka yung predicted value plot. However, in this particular case, we will do the formal test. We are going to use the Bruch-Pagan test. However, the Bruch-Pagan test is not available in SPSS. So we have to add that macro in our software. But the adding of macro is just very simple. So what happens if hindi equal yung variance natin? So we can do the weighted least squares para ma-stabilize yung variance natin. Okay, this is according to Hare et al. So Haas-Vaughan summarizes the violation of assumptions in this table. Okay? Okay, now so let's take a look at our sample study here. So the working title is the effect of learner, instructor, and learner-learner interactions on online class satisfaction. So this is our conceptual framework. So ito yung independent variables natin, and this is our dependent variable. So yan. And then of course, para align yun, it is very important na yung conceptual framework mo, yung title, yung statement of the problem, at saka yung hypothesis natin are aligned. So that is why in this sample study natin, I presented those major parts. So the statement of the problem in this particular case is thus the learner-instructor and learner-learner interaction influences online class satisfaction. So the equivalent hypothesis natin dito, since dalawa yung independent variables natin, so of course we also have two null hypotheses. So the first hypothesis is learner-instructor interaction does not significantly influence online class satisfaction. So for number two, hypothesis number two, learner and learner interaction does not significantly influence online class satisfaction. Okay, similar lang, the difference is just the learner-instructor at saka yung learner interaction. Kasi we have to test if may significant influence ba itong variable na to our dependent variable and also this variable to our dependent variable. Okay? So assuming that you already gathered your data, let's now take a look at our SPSS. So let us check first our checklist kung ano yung unang assumption na gagawin natin. So, let's reset this one. So the first is the homoscedasticity using the Brioche-Pagan test. So how are we going to do that? So by default, this test is not included in SPSS. So that is why you have to install the macro. I will add in the description below the link that I followed to install this macro. It's very, very simple. Okay, so let's now do the test. You go to Analyze, assuming that you have already installed the macro, you go to Analyze, Regression, then this portion here. Okay, for the outcome variable, that is the dependent variable natin, which is the satisfaction, and then the learner, instructor, and learner, that is the explanatory or the independent variables. Press mo lang and then just press OK. So based dun sa checklist natin kanina, the value should be greater than 0.05. So let's check the output. Nasa dulo yan. The B3, BP, the Brioche-Pagan statistic, is 0.37357. So that is greater than 0.05. So therefore, this is compliant. Okay? So next is the linearity. So the relationship between the DVs and the IVs is approximately linear. This can be checked using the matrix plot. So how are we going to do the matrix plot? You go to graph, legacy dialogues, and then scatter plot, and then we will check the matrix scatter plot. Then define, and then reset this one. Just select all the variables here. So study natin, dependent at saka independent. Then just press OK. So yung kailangan lang natin dito is this one, which is the relationship between the graph between the satisfaction, the learner, instructor, and then the learner, and then the satisfaction graph. So as what we can see here, we can approximate that this is approximately linear. Okay, so go back to our PDF. Linearity is compliant. Next is the no influential cases. So in order to perform this one, we have to run regression analysis. So how we're going to run regression analysis? Analyze, regression, then you go to the linear. And then just reset this one. So the dependent variable, ipasok natin yung satisfaction. And then the learner structure dito sa independent. We will do the inter method first. So statistics, we can do the descriptives, the collinearity diagnostics, the Durbin-Watson to check for the autocorrelation later on, the case-wise diagnostics to check for the outliers with standard deviation outside 3 standard deviation. Continue, plots. So, yung plots kanina sa lecture natin, which is yung the y-axis, yung sa y-axis natin is the residual, standardized residual, and then the x-axis natin, yung kanina, is yung standardized predicted values. And then just in case you're going to need the studentized residual, so ang gagawin natin, same pa rin, yung residual natin dito, standardized, studentized residual for the y, and then yung standardized predicted value natin is yan. Then you can check for the histogram, then the normal probability plot. In this case, you will not need produce the partial plots because we already checked the linearity using the matrix plot. Just press continue and then for the save. So other tutorial will tell you to, and other books will tell you to click this one and standardize. But in this particular case here, we only need to run these standardized residuals for us to test the normality of our data later on. Then for the distance, we will check the Cook's distance. Ito yung gagamitin natin for our next test. And then, just press continue. Then let's say for the options, okay na yan. And then just press okay. Okay, so let's go back to our checklist. Ano ba yung nandito? No influential cases. The Cook's distance should be less than 1. So saan natin makikita yung value na yan? So you go back to your original data set. So may values na nadagdag. This one is the standardized residual and then this one is the Cook's distance. So dapat daw yung value natin dito should be less than 1. So how are we going to do that? Mas madali na i-sort natin to either ascending or descending. So the highest value is 0.15. So therefore, yung influential case natin is complied. That there is no value greater than 1. So next is the normality of error terms. So using the Kolmogorov-Smirnov or the Shapiro-Wilks test, statistics should be greater than 0.05. So are we going to do that? You go to the analyze, descriptive, explore, and then you drag the standardized, the newly created variable, standardized residual, dependence list, and then you go to the plots, and then make sure na naka-check yan. Okay, yung normality plots. You can the stem and leaf. Let's try to see the histogram. So just press continue, and then just press OK. So tingnan natin yung histogram, standardized, so approximately normally distributed. So, yung formal test natin, we will take a look at the Kolmogorov-Smirnov at saka yung Shapiro-Wilks test. Kanina, sabi yung sa checklist natin should be greater than 0.05. So, the sig value here is greater than 0.05. the sig value here is greater than 0.05. So therefore, this one is checked. Independence of error terms. The Durbin-Watson statistic should be close to 2 or not less than 1. So balik tayo kanina, and then saan natin makita yan? Dun sa previous na na-run natin kanina. Yung sa regression, you can just click here. Yung sa regression. And then nandito yan sa model summary. So the Durbin-Watson should be closer to the value to 2. It should not be less than 1 or greater than 3. So in this particular case here, okay tayo. So 2.2. So ibig sabihin yan, close to 2. Good. And then no multicollinearity. So we are going to check for the multicollinearity using the variance inflation factor or the VIF. So score should be less than 10. So saan natin makita? Same pa rin, dun pa rin sa regression na test. Mas naunang na-perform natin. So just in case na wala, ulit mo lang. Regression and then linear. And then just press OK kasi nandun naman yung by default niyan. Okay? And then tingnan natin si VIF. Yung VIF natin is around here. Yung VIF natin should be, sabi sa checklist, yung VIF natin should be less than 10. So in this particular case here, yung VIF ng dalawang variables natin are less than 10. So therefore, okay tayo with our assumptions. Now, let's proceed to the interpretation of our MRA. Assumptions pa lang yun. Dito na tayo sa interpretation of our regression model. Okay, so let's start with the model summary. So the model summary under this R square is 0.76 will tell you how good is the predictive capability of your model. Okay, so our R square here is 0.76 or 76%. It means that 76% of the variability in the online satisfaction can be explained by the learner interaction and learner-instructor interaction. Okay? So the higher the value of your R square, the better is your model. So although yung R square natin is mataas, let's now take a look at the model adequacy. Okay ba yung model natin? So makikita natin yan under the ANOVA. Under the ANOVA, the sig value here is 0.00. So it means that our multiple regression analysis model is significant. So basically, yung tinitest ng ANOVA nito is that the null hypothesis or beta is equal to 0. So since yung sig value natin dito is 0, so it means it rejected the null hypothesis. It means that there is a significant beta value. So that's the deeper meaning of why we use ANOVA in this particular test here. But in interpretation of your regression analysis, the ANOVA is used to test the adequacy of your model. So ibig sabihin yan, okay yung model natin. So using now this coefficient table, we can now create our MRA model. So using the notepad, this is our model. So our dependent variable is the satisfaction, equals mo lang. And then 0.264, that is the constant. Saan galing yan? Nandito yung constant natin. This is the beta sub 0. Yan yung constant natin. And then, the learner instructor, the coefficient is 0.388. Yan. And then the learner coefficient natin is 0.588. Okay, so yan yung magiging model natin. And then, of course, we have to check kung significant ba yung mga variables natin. Let's check for the sig value here. The sig value is less than 0.05. So it means that we have to reject our null hypothesis 1 and null hypothesis 2 and state that learner-instructor and learner-learner interaction significantly influence the online satisfaction of our students. Okay? So, lahat ng mga files na nandito na ginamit natin, I will upload it dito sa description box below. And if you have some questions or clarifications, please comment down below the video and I will try to answer your questions as soon as I can. So, good luck and see you.